The reason I requested that you guys check out the video tonight is I want to show you a shortcut for solving these problems involving what we call the Goldilocks triangles. Our shortcut, not surprisingly, is going to involve the geometric mean. In both of these diagrams, we see the altitude of the largest triangle in red. The shortcut involves looking at the altitude and knowing that it is the geometric mean of the two segments it splits the hypotenuse into. So for example, in this first problem, we would say that x is the geometric mean of 3 and 6. In the second problem, 10 is the geometric mean of 3 and an unknown x. And so we're going to use this very interesting application of geometric mean to make these problems quite a bit easier. If you remember correctly, the geometric mean requires multiplying the two numbers and then taking the square root. So for example, number 1, x, which is the geometric mean, is equal to the square root of 3 times 6. 3 times 6 is 18, and the square root of 18, we can use a calculator, is 4.2. And so we can certainly agree that this method, at least for this first problem, is a much quicker way of finding the geometric mean. But how would we do the second problem where the unknown is not the geometric mean but one of the segments? We're going to use the same exact formula, only when I say the geometric mean is equal to the square root of number times number, I'm actually going to know the geometric mean, which is 10, but I won't know one of the numbers, and so I'll refer to that as the x. So here, 10 is equal to the square root of 3 times x. We'll solve this problem by squaring both sides. And so now we've got 100 is equal to, now the squaring and the square root cancel each other, and we just have 3 times x. We'll divide by 3 on both sides. And I'm left with x is equal to 100 divided by 3, which is 33.3. So still quite a bit simpler than drawing out our 3 triangles. Hopefully you guys checked out the video and it makes the homework quite a bit easier.